Good morning, good afternoon, good evening, everyone. Welcome to the week 3 of Web Application Security Bootcamp. So today we'll take a look at A1 injection attack, specifically SQL injection, NoSQL injection attacks, as well as security misconfiguration and why it is important to make sure we are logging all of the error messages and all of the attempts, request attempts, and all of the data in case of web applications. So before we start or go on with the session, any questions so far with respect to the previous sessions or all of the attacks which we have seen in the previous sessions? Any questions? So some of you have been asking regarding the code for the command injection based vulnerability, right? So I completely understand many of you might not be familiar with the JavaScript based syntax. So I'm going to walk you through the code from a very high level. So here we can notice we have the event path, right? And if we'll scroll down in here, just a second. Yeah. So this is a function which is being called when we hit the API endpoint. And here we can notice we have the event body, right? So basically we are fetching the body of which is passed in the event data, and then we are checking if it is base64 encoded. If it is base64 encoded, then we are basically performing base64 decode in here. And then we are calling a function called put, and we are passing the dest bucket key as well as body. So here we have the body as again the file content, dest bucket is the destination bucket, and key is going to be the name. So as you can see here, what we are doing is we are basically fetching the last value which is after the or at the end of the endpoint. So now let's take a look at this specific function, and this is where the vulnerability is introduced. So if we'll go down in here, here we have the put function, right? And this is the destination bucket key as well as data. So now this is where the problem begins. We have a function call, which again executes a command. Here we are calling the exec function. And this is basically what it is doing is it is echoing the date, and then it is appending the key name. So let's say the file name is, just a second. Let's say the file name is hello.png. So what this is basically doing is it is taking in the date, which is going to be again in a format. For example, let's consider today's date, which is 30/05/2021, right? It is going to take in that name, and then it is going to append this string to that date. This way, what happens is it gets a unique object or a unique name for this specific file. And this again introduces a misconfiguration because we are not performing any sort of check-in here, right? So that's why whenever we are injecting a command injection based payload such as semicolon, it goes ahead, executes the command, and in turn it leads to a vulnerability. So the best practice for the developer would have been, again, not to use the exec function at all here. This is because, again, it is not required. We can go ahead, use one of the modules available in the Node.js itself to do this sort of operation. And another issue is that we are not performing any sort of checks, right? Any sort of sanitization or anything like that. So this is, again, we have to make sure we create a box character. So this could be A to Z and capital A to Z, 0 to 9. And we can have select characters which are allowed in the file names, such as, again, hyphen is allowed. So we know that hyphen is allowed. So now whenever we find a character which does not belong in this specific set, we simply replace that character, such as, again, semicolon, ampersand, all of those by hyphen. So this way we have a name. Again, now we are passing in a sanitized command to the exec function. This way it does not lead to a command injection based vulnerability. So any questions? So this is to answer the question of Jati, but if SAST is done on code, then it's going to be identified. It depends. And this is to answer the question of Justin, rather than using grep or search function, how best is to find these vulnerability in source code. So again, the best way is for a developer who is familiar with security features for, again, all of the languages, how for example, how we have to use various functions, what are the security risks associated with these functions. And that's probably the best way to, again, perform source code auditing. And this way we'll be able to identify misconfiguration, right? We need to have a developer who is familiar with all of this language specific security. Just a second. Language specific security constraints. Web pen tester. So uh, it will be, if you're not familiar with the language, it is going to be very difficult, because again, the only way as a web pen tester we can do is we can perform black box pen testing. We can inject payloads to try it out. But if you're not familiar with the language, if you're not having the developer background, it would be very difficult to do that. You'll need some familiarity with the language and the security issues related to the various function calls. Yes, that is correct. Most of the time when you're performing pen testing, it is going to be black box pen testing. And in case if you're provided with the source code, you need to have some familiarity with the language on which the application is built out. And personally, I think that's the only way we can make sure that these kind of vulnerabilities are not there in the source code. So any other question? One easy check which we can do is, again, make sure that it is very easy to take a look whether sanitization is being performed on the user input, and that would be the first flag, right? So for example, if we have identified that a variable such as key in here, no sanitization is being performed, then that provides us with some insight, right? Even though you do not have too much knowledge of the language itself on which the web application is based. So next we are going to start with, again, A1 injection attack. We have seen command injection in the previous session. So we have two more lab exercises. These are the home labs, and these are based on PHP backend. So you can try these out after the session. And we also have a PHP code injection. So these are very similar to what we have seen in the previous case. The only difference in here is we are going to execute other commands apart from printenv, because printenv was used in case of cloud environment, and specifically in the Lambda environment, because environment variable is where the temporary access credential reside. Now, next we are going to take a look at one of the most popular injection attack, which is SQL. So here we have the top web attack vectors, and here we'll notice 65.1% is SQL injection attacks. Now, it is deemed very severe. We'll talk about why it is deemed so severe in just a minute. But again, if you'll take a look at past couple of years, you'll notice that this is a vulnerability which is not, completely disappearing. It is still there in the security domain, and attackers are still being able to leverage it. So now, whenever you identify a SQL vulnerability, it is classified as very, very severe. The reason being, what happens is it starts with a simple website, right? So in this case, what we are going to do is we are going to assume that the uh, attacker does not have any sort of access to the web application, and this web application is like a normal application which have uh, some sort of form fields and login forms, etc. So now the attacker is able to identify a domain which is hosting this application, and the attacker finds the form field in here. So now the attacker is going to do is he's going to inject the SQL payload in these form fields. Now, if this web application is vulnerable, what might happen is the attacker might be able to bypass the authentication. That is the first case. The attacker bypasses the authentication to access some sort of privileged content or sensitive data. The other issue is then, because this page is vulnerable to SQL injection attack, the attacker can go ahead, steal all of the data which is present in database. So now we know that there could be user details, such as, again, for example, we'll have username, which is mostly stored in plain text. Then we have password, which would be in hashed format. And then we have other sensitive details regarding the user. It all depends on the web application, right? For example, if it is e-commerce, we'll have the uh, address details of a user, will have their PIN code, will have their phone number, personal details, credit card information could even be there, right? So that's why whenever we have a SQL injection vulnerability, it is deemed as very, very severe. Now let's take a look at what can happen, or what is the worst scenario in a SQL-based attack. So now the attacker does not have any prior access to the web application. The attacker goes ahead, performs some information gathering to identify a domain. So this could be www dot maybe webapp.com, and this is again a domain which the attacker identifies, and the attacker finds form field on the web page, right? And the attacker goes ahead, injects the SQL payload in here, and it bypasses the authentication. So that is the first issue. We are now inside the web application, and then we'll also be able to again dump out all of the credentials. So now let's say the the attacker is able to dump out the hash of various users. So this could be admin user, this could be local user, this could be editors. Again, all of the various kinds of user which there are on the web application. So once the attacker has the hashes of the password, now we assume that many people will not use easy to guess simple password, right? But in reality, what happens is many individuals, they use easy to guess password. This is because, again, it is very easy to remember, right? So many times individuals use simple password to, again, make sure they remember it. So now these hashes can be cracked with, again, either with tools such as hashcat, John. And once these hashes are cracked, the attacker gets hold of the plain text password. So now let's say the attacker is able to get hold of the admin username as well as the admin password. And now let's assume that this application is a WordPress application. Now, in case of WordPress, what happens is if we are an admin, then in WordPress, we can go ahead, modify the template, we can modify the web pages, and we can also create web pages. So when we are creating a web page, so let's say we have maybe a file called template.php, right? So if we have the script, we can modify it to inject a simple backdoor or a web shell onto this page, right? So once we inject a web shell, so this again provides us with a Linux shell onto the server on which the application is running. So at this point, the attacker goes ahead and gets hold of www data user. So this is again the default user by which Apache as well as Nginx uh, are running. So once we are www data user, the next task of the attacker will be to again identify the misconfiguration, identify the vulnerability which could be on the server, and then escalate privilege to ultimately become root, right? And now once we are root, this opens up a whole new horizon for the attacker. So attacker can go ahead, use this machine to attack other servers on the internet. And if the server resides on an internal network, we can go ahead attacks on the machine, other machines on the network as well. So now if we take a look, it all started with this step, information gathering, right? We were able to identify a domain. We went ahead, injected a payload onto the domain. And if the authentication bypass itself does not provide us with admin privilege, we go ahead, crack the hash, get hold of the actual password, interact with the application, and then get a shell on the server as www data user, identify the misconfiguration, and then become root. And this, again, this process continues, and we attack other servers on the same network or other servers on the internet. So now it's not required that, not always be required to be root. We can also perform attacks through www data user. So even if there is no misconfiguration, it still provides us, or still provides the attacker the opportunity to, leverage the vulnerability on the application. So any doubt in this part? So this is why, again, it is very, very severe. SQL injection is deemed as very severe. And one of the important thing is that even if we are not able to, again, maybe get WW data, let's say this does not happen, right? This is some application which does not allow us to do any kind of modification to the existing web pages, but still we are able to dump out the user credentials, right? So user data is very, very sensitive, because again, companies get sued for data leaks and all of this issue. Once an attacker gets hold of user data, such as again address information, they can perform a lot of attacks directly on the user, and they can steal thousands of dollars from them. So this is how many of the scam happen. So any question in this part? Any question? So now in case of SQL databases, these are the popular SQL databases. We have MySQL, we have Postgres, and we have SQLite. And the important thing about these databases is they are relational databases, right? So there's a structure in which the data is stored. So next, this is a home lab. This is again, if you're not familiar with SQL, you can go ahead, try this for now. And this is how SQL injection happens. So this is again a form field. Just a second, let me quickly. Yeah, so let's quickly jump into a demo, and I'll explain everything in the demo. So I'm going to forward this a little. First of all, we are going to identify the IP address and perform the nmap scan to check the open port. So we have the port 80 open, so we are going to navigate to the web server. And here we have a vulnerable application, which is bwop. Now the credentials are mentioned in here, so we can directly feed it to the application, debug. Now we are going to navigate into the SQL injection login form, right? So now here we have a login form. So now we are going to start up Get It. This is just to help you understand what exactly the query is behind the scenes. So I'm going to write out the query in this specific text editor. And when we are going to try various payloads, we'll take a look at what exactly is the query which is being executed behind the scenes. So this again, while trying the lab, you do not have to try this one. This is just to help you understand the query. So now whenever we have a form field, we can speculate that probably this is the kind of query which is there. So here we have select star from heroes, where login is equal to username and password is equal to whatever password we pass in here. So can anyone, so it's a question to all of you. So how many of you are familiar with SQL, and for how many of you this is the first time with SQL? Okay, so I'm going to try to explain this in the simplest way possible. So people who are not familiar with this will also be able to understand. So now behind the scenes, what happens is, just a second, let me draw this one out. So now the data in the database is stored in a table, right? So here we have the username. So I'm going to mention this as user. This is password. I'll refer this as pass. Then we have a couple of property. This could be, again, the date of joining, or the date of birth, and we can also mention this as the reset question. So I'll refer this as RQ. Now in the database, we have data stored in this format, right? It is in a form of table. So now we have the user data mentioned in here. So I'm going to put in the value David, and here I'm going to mention password as pass. And here we can have some random value. Similarly, for this one, we can have some random value. And here I'm going to put in James. Password is going to ABC. And here I'm going to put in John. Password is going to be DEF. And here I'm going to put Alice. Password is going to be 123. Right? So this is, again, we can speculate that the data in the database is stored in this format. So here, the table name is going to be, again, this table is heroes. Right? So in database, for example, it could be users, it could be anything. But while we are performing SQL injection, first of all, we are not concerned of this name, right? This name is not important while we are performing initial set of SQL injection payloads. So now what happens is whatever value we put in here, username. So this is, again, the username, and this is the password. So whatever value we put in is going to be substituted in this query. So here we can notice this value is going to be substituted in here. Then the password is going to be substituted in here. Now, what this query is going to do is it is going to iterate over all of these records, and then it is going to check where login. So I should have mentioned this as login. So for the time being, we can consider this field as login, and let's give this as password itself. So now what this statement is going to do is it is going to iterate over all of these records, and not the first one. It is going to, this is again the header of the table, right? So it is going to iterate over these records, and then it is going to check whether login is equal to the user name which is passed. So let me quickly play the video. So here we have entered John and Doe, right, as username and password, and it says invalid credentials. So now what happens is when we enter John and Doe, the username is John, and then we have password as Doe, right? So it goes ahead, compares these value in the record, and it checks for the first record, it checks that username is not equal to John, and at that time itself it returns that, okay, first row does not match, let's move on to the next one. The next one, it checks username is not equal to John, so this also fails. In the third one, it checks username is equal to John, so this condition is true. The first statement is true. Now it goes ahead, checks for the second statement, and it checks that password is not equal to DEF, so this is also false. So the third row also failed, and in this case it also fails, right? So similarly, it goes ahead, it iterates over each and every row, and if it does not find a match, then it is going to return invalid credentials, right? So this is how this specific statement is processing all of the parameters which are sent to it. Now next, we are going to try out a very simple payload. So this, again, we are injecting the John and Doe in here. And now next what we are going to do is, let me clear this one up. We are going to inject a single quote, and this says you have an error in your SQL syntax. So here, this is the query which is executed, right? So when we injected the single quote in the username, this is what happened. Just a second. So as you can notice, we have triple quote in here, right? So the first quote, so here we have the first quote which is being terminated by the quote which we entered, and then we have the quote of the application itself. So this part does not make any sense because this in turn creates an invalid syntax. The first quote is being terminated by the second quote, so this is again very well terminated, but then the next part which is this part, is again out of place, right? So this again results into a invalid syntax. So here we have the unclosed single quote, and then the remaining statement becomes invalid. So now, next, we are going to inject, just a second, let me quickly increase the speed of the video a little. So next, we are going to inject very simple SQL injection payload, which is 1 or 1 equal to 1. And then we are going to inject this specific payload in the input in both of the field. So here we can notice if we inject this specific value in the username, which is single quote or 1 equal to 1, right? So if we inject this specific payload, the first single quote is going to terminate the first quote which starts in here. Then this part, right? So or 1 equal to 1, and this single quote, which is this one, is going to be terminated by the quote which was already there in the query. So now we have one single quote added in here. So now this is one condition, this entire thing becomes second condition, and then we have another third condition, which is again whatever password we will pass in here is injected in here. Now the important thing to note here is we have an or statement, right? So whatever the result, so for example, if this is true or false, it does not matter because this condition is true, right? 1 equal to 1, this is going to be always true. And similarly, we have true or false, right? So it does not matter what this is, it does not matter what this is, because we have or statement, which is again, which has a condition which is true. So this entire statement is going to be always true. So this way we are going to inject the same payload in here again. And here we can notice that this is always true. This is because or 1 equal to 1, this statement is true. Similarly, this statement is true. And no matter the condition in here, which is again login password, this entire statement is going to be true. So that's why upon injecting this payload or 1 equal to 1, the authentication is bypassed. And here we have a message, welcome Neo, how are you today, right? And then the secret is revealed. So this is again how a simple payload, this is commonly known as again one of the simplest SQL injection payload. Whenever you are checking for a SQL injection vulnerability, this is the one you'll try at first. And now we are going to take a look at another payload with comment. So now double hyphen in SQL is the comment, right? So whatever we have after the double hyphen is assumed as a comment. So here, as you can notice in this payload, we have simply modified and we have added a single quote in here and we have added double hyphen. Now, what happens in this case is when this is injected in here, this is the first condition. This is the second condition, which is always true. So irrespective of this condition being true or false, it does not matter. And then we have double hyphen in here followed by a space. And now what happens is when the SQL Server is processing this query, it's going to check that there is double hyphen. So it is going to assume that whatever is after the double hyphen is a comment, right? So this is treated as comment. So this way, if we have a complex SQL statement and we are able to inject this payload, it is going to comment out the remaining part. And this again results in the authentication bypass. Yeah, unfortunately, just a second, let me enlarge the video itself. Uh, Apart from this, I will not be able to increase the font size. I'm not sure if I can. Just a second, let me check if there is an option in Zoom itself. I think you can also increase the size on your end. I'm not sure if I can change the size directly in here. So here, what happens is this again leads into authentication bypass because this part is treated as a comment. And then this is again the true or false statement, and then we have a true condition, which ultimately leads to authentication bypass. Now, the important thing to note here is that after double a hyphen, we need to have a space. It is very important to have a space. If you do not have a space, it is going to result in a syntax error. This is because how this comment is used. So in case of MySQL, we need to have space after the double hyphen. So now if we'll inject this payload, it will go ahead and lead to authentication bypass. So I'm going to forward this a little. So we're going to try and copy paste this one in here. And now it is not required to enter a payload in here, and there we go. So now we have one more option, which is hash. So there are two type of comment. We have hyphen hyphen and we have hash. Now the beauty about hash is we do not need to have space after the hash. So here, this space is not actually required. So we can go ahead, mention the hash as it is without any space, and then it is going to refer to the remaining part as a comment itself. And this statement also returns in always true. So this way, again, we are able to bypass authentication. The difference between hash and double hyphen based comment is that we do require a space after the double hyphen. So that is again, if you do not have that, it won't result in a SQL injection, or basically it will result in a SQL syntax error, which will in turn prevent the exploitation of the vulnerability. So now we are going to take a look at the next one, which is again string-based comparison. So here we have a very simple form where we can go ahead, enter a value, and then it is going to search various records to see if that value is present in the title of the movie. So it depends. So this is to answer the question of DKL cost. So apologize if I'm pronouncing your name wrong. Does it default to the first user in the table when running payload in the user field? So for example, let's say we have the table in here, right? So the SQL query, it's going to, again, once it processes the first record itself, it is going to return this record. So the user details are going to be of the first user, but now it depends how the application is processing the data. For example, the application could check whether any records are being returned, and then it is going to, in this case, for example, if we'll go back in here, in this case, we have the new message displayed, right? So what the application is doing is it is basically checking if the record returned are 0 or not. If it is non-zero, then it is going to print out this message. Otherwise, it is going to print out invalid credentials. But in normal application, what happens is the first record will be returned, and then we are going to use whatever user details are there to, again, initialize the entire web application. So in some cases, there will be, again, statements such as limit. We'll talk about, we'll take a look at how limit and everything works. So sometimes there might be limit-based checks as well. But most of the time, you'll notice it as a first row itself. There could be also sorting, right? So based on that, if there is sorting, then whichever user comes up in the list at first, those details will be picked up. So next, we are going to take a look at the search, a search feature of the application. So here we have this specific statement, and previously we saw that we were injecting the script, or we were injecting the input, and there was equal to based comparison, right? So in case when we want to perform partial match, or we do not want to match the entire string completely, we use the like operator. So now the difference here is that instead of equal to, we are going to use like. So we have equal to mentioned in here, right? So instead of that, we are going to use like. Now, in case of like, what happens is, let's say we type in a string hello, and now here we have wildcard characters, which is percentage. Now, if this is, if we are performing like hello percentage, then what it is going to do is, it is going to check in the database for all of the records. And let's say we have a statement hello from uh, maybe Alice. And here we have another statement, let's say hello from John. So now what happens is, this statement will go on, iterate over all of the rows, and it is going to check that this specific string, it is going to match it character by character. So it's going to match, this matches, first character match, second character matches, third character matches, fourth character matches. And then we have a percentage, right? So whenever there's a percentage, it means, again, it's a wildcard. So it is similar to star, right? Star in Linux. So whatever string there is, it will be matched. So here we have this entire string, right? So it is going to match this string. So the first record is checked. Now let's say we have hello, or let's say we have hell, and we have a space in here, and let's say we have something else, for example, uh, Bob, right? So this is again a simple string which we have. So while a check is being performed in this case, it is going to check that the last character, which is the fifth character, is not going to match, and this again does not pass the check for the this statement. And here it is going to check again for all of the characters, first, second, third, and fourth, fifth as well. So all of these matches. So it goes ahead, and the wildcard again matches with this entire string, and this with these two records will be returned. Uh, for a single character, we have underscore. So for example, if we have hello underscore, then it is going to match a single character. So in this case, this is going to fail, this is going to fail. And let's say we have another, which is hello 5, and this is going to pass, right? So this is how like works. So next, whatever string we are going to inject in here will be injected in here. So first of all, we are going to try, now in this case, we have double percentage, right? So we have percentage hello percentage. So it is basically looking for substring. So for example, let's say we have Alice says hello to Bob, right? So now we have a substring. So this statement, it cares only about this substring, right? So we have one set of string in here, which is going to match this specific wildcard. And similarly, we have one set of string in here, which is going to match this specific wildcard. And this matches character by character, right? So this is going to pass the check. Now, if we'll have hello from Bob, this will also match, because again, we have null character in here, right? So it is going to consider null or a string. So this will also match. Similarly, again, if we have a string which does not have a hello, it is not going to pass the check, and this statement will not return any results. So now we are going to inject a single quote, and when the single quote is injected, the value is substituted in here, right? So we have one single quote injected in here. Now this in turn results in an invalid syntax, because we have one single quote which is being terminated by another single quote. But after that, we have percentage and single quote, which is again invalid. So next, what we are going to do is, we are going to use the or 1 equal to 1 payload. And this is going to match as well, right? Because this statement, we have 1 equal to 1 percentage. Now we know that percentage is going to match either an empty string, or it is going to match a set or a set of characters, right? So in this case, this condition is also true. So the same payload which we used in the previous case is going to work out. Yes, so this is just to clarify that the SQL statement is actually in the PHP code, and whatever input we are passing in here, that is being injected in here. So again, as you can see, we have this mentioned in here, right? We have value and this. So in this place, whatever value we pass in the form, which is in here, is being substituted. So for example, if we inject single quote, a single quote is replaced in the value in here. Similarly, if we pass the or 1 equal to 1 payload, that is substituted in here. So that's again how the query is executed behind the scenes. So again, similarly, we can go ahead use the hyphen hyphen as well as the hash based comment, and this will also return us with the same result. So next, we are going to take a look at another example where we have the get select based. So here we have a drop down menu, right? And we can go ahead, select a movie, and then we can click on go. Now, can anyone tell me an interesting point about this web page? Where are you going to inject the payload? ID, where is the ID? Yes, that is correct. So we have the URL, right? And if you'll notice, upon clicking on or selecting a movie, we have movie is equal to 1, right? Now here we can notice this is an integer based value. So now we can speculate that the query is going to be slightly different and they're not going to be equal to in there. Because again, this is an integer based check. So whenever we are performing integer based check, we won't have string comparison. So if we'll just a second. So this is again the SQL query which you can speculate. So here we have the value which is passed in here is replaced in here. So if you're going to inject the value 1, it is good enough. And if we'll inject single quote, it in turn returns a syntax error message. So now, now we know that there is no single quote, so we can simply mention or 1 equal to 1 without any sort of single quote, and this in turn, whether ID exists or not, we can go ahead. This condition is always going to be true, which in turn will make the entire statement to be true. And now this is very interesting, right? We only get one record. Can anyone tell me why this is happening? We injected a payload, right? So ID 1 equal to 1 is true, and then we have a always true statement, right? So but we have an always true statement, so irrespective of the ID, it should again evaluate true for all of the records, not just the first record. Yeah, that is also correct. It is selecting the first record, right? So for example, let's say it returns, let me draw this one out again, just a second. For some odd reason, I'm not able to draw. No, now I can. So now let's say it goes ahead, matches for all of these 3 rows, right? But it's going to return us only the first record. So that is again correct. Now the question arises, how are we going to iterate over other records and get all of the data? So this again, this returns us only the first record. So this is where something called limit comes into the picture. So what we are going to do is we are going to use limit clause because again, it is how the web application might be coded. So for example, it expects the ID to be 1, right? It expects only one value. So what happens is this query execute, although it returns all of the records. So here we have 1, 2, 3, 3 records. It's going to process only the first record. So you can imagine if you're familiar with Python, we have a list of objects, right? So you can consider this a list where you're only fetching the first object. So let's say we have result, right? And so we are checking if result is not equal to, or the length of result is not equal to 0, and then we are fetching the first result. Based on this, we are getting all of the data, such as again the title, release, character, and genre. So this is again, it is not iterating over all of the result and printing it, it is just fetching the first record which is returned. So now this is where we are going to use limit clause to get the data. So now let me, just a second, I remove this one. Let me clear this one up so that it is easier to explain. So now here we have, let's say this is the first record. So we are not mentioning the header in here. This is all the record there is, right? So this will have the index 0, 1, 2, 3. And this is again the first record, second record, third record, fourth record. So when we mention limit clause in an SQL statement, what happens is this indicates how many rows are to be fetched. For example, if you mention limit 3 and we have a SQL statement in here, right? For example, just a second, let me erase this one as well. Let's say we mention limit 3 here after this statement, right? After this statement, we mention limit 3 here. So what it is going to do is it is going to fetch all of the records and it is going to return the first 3 records only. So although all of the records are matched, it is only going to return the first 3 records. So this is again the limit clause. Now this happens in case if there is only one value which is passed to limit, right? So here we can notice there is single value. Now if we'll have multiple values such as limit 2, 1, so now we have multiple values, right? So these are separated by comma. So what it is going to do is it is going to fetch the record from second offset. So this corresponds to offset and this corresponds to number of rows. So here it is going to fetch record from the second offset. So here this is the offset we have 0, 1, 2, 3, right? So it is going to fetch the value or the record from the second offset, which is this one, and it is going to fetch number of rows, which is 1. So it is going to fetch and return this specific row only. If you have 2, 2, it is going to fetch these two and then it is going to return that. So this basically is the offset, and we can also reference this as index in case of MySQL table. So now it will start from 0, 1, 2, 3, and based on this, it is going to return a result. So what we are going to do in this case is, here we are going to mention the limit as this, right? So this is the statement which we have. And now upon injecting this, we are going to, again, this is actually the third record, not the second record. So there's a typo in here. So now we get a different value, right? So basically now what we are doing is we are telling the SQL query to, just a second, let me draw this one out real quick. So now basically we are telling the SQL query that of all the records you have matched, fetch me the third record, which is again 0, 1, 2, right? So this is again the third record because the offset is second, and we are basically returning only one record at this point. So that's what we have the limit for. So limit 2, 1 is going to fetch us that value. Now we can go ahead change the offset accordingly. So this way it is going to, in this case, it's going to fetch the fourth record in here, which is again at offset 3. Now this way we can go ahead iterate over all of these records, right? So previously, as we have seen, without the limit clause, it was only returning the first record. Now with the limit clause, we have the capability to go ahead, iterate over the entire table and dump out all of the information. So let me clarify on this part. So this is to answer the question of leaf rag lies. This necessitates that you know the DB enough is to provide precisely which entry you want. If you use limit 2, 1, it looks to me if we use limit 2, 1, we have to know. Yeah, let me explain this part again. So I think it is confusing for a couple of people. Just a second. I'm looking for clean space. So let me draw this one out. So here we have a table and here we have multiple records in there, right? So now this is the first record. Oops. This is the first record. This is the second record. This is the third record. This is the fourth record, right? And now we have, let's say we have one more column in there. And now we have the ID itself. So this is 1, 2, 3, and 4. And this column is the ID column. So now we know that ID is 1 in here. So since it is going to match ID is equal to 1, and then we have another condition or 1 equal to 1, right? So this returns all of these record 1, 2, 3, and 4. Now what the application is doing is it is only processing the first record. So for example, let's say in terms of, I can reference it with the easiest example of Python code. So let's say we have a result list, right? So this is again a list, and list, as you know, contains multiple objects, right? So it is going to check the code. What it is doing, it is checking whether result has the length of 0 or not. If it does not have the length 0, then it is going to fetch the first object, which is again result 0, right? So this corresponds to the first object, and here the first object is this one. So irrespective of what ID we mention, if we have two, it is still going to fetch us again the first record. This is because all of the record are returned, and this specific operation is only providing us or only displaying the user with the first value, right? So that's why here, whatever ID we provide, it is going to provide us with the first record because we have a true condition, which in turn returns all of the records. So now with limit clause, what you're basically doing is we are telling that although the condition is true for all of them, I only want a specific row. So in this case, when I mentioned 2 comma 1, so now the offset is going to be starting from 0, 1, 2, 3, right? So when I mentioned limit 2 comma 1, I'm basically referencing that instead of returning me all of these records, which is again all of these records, you provide me an exact record which starts its offset 2 and provide me one row, right? So this in turn is going to start at offset 2, which is this one, provide us one row, which is the third row. So this way, we can go ahead, iterate over each and every record. Now the second one, so for example, now one can question that if I mention 2 comma 50, this is supposed to return me all of the records starting from second offset to the remaining offset, right? So in this case too, remember this restriction, right? So since the web application code itself is only fetching or providing us with the first record, it will provide us with only the third column. It won't provide us with the other, or sorry, it will only provide us with the third row. It will not provide us with information about the other records. So that's why we have to go ahead, change the offset value, which is in this case 2 comma 1, 3 comma 1, 4 comma 1. If you change this value, this corresponds to number of record. So now the web application is only providing the user with the first record. So this number does not matter. So this is where we have to, again, modify the offset, keep on modifying the offset to dump out the entire table data. So any doubt in this part? Yeah, no, it's completely okay. This again, bootcamp is supposed to be very beginner friendly, right? So the more question you ask, the better it will be. So that again, if other individuals have any doubt, it will clarify everything for them as well. So any doubt so far? Okay, so let me clear this one up. So now next, uh, let me forward this. So next we can go ahead perform the same injection. So previously, in all of the previous injection, we were performing parameter based injection, right? So all of the data was going into the URL parameters. So this is an example where we can go ahead and inject payload into the post data. So here we can notice the URL does not have any parameter. So this is where we'll have to start a burp suite, intercept the request, and then send and inject the payload. So this is again, we are configuring burp suite. And now once we have the request, we can go ahead. This is just, we are changing the font size so that it's visible to everyone. Now, once we have intercepted the request, we can go ahead, send this to repeater. And from the repeater, we can go ahead, tamper the request just like we did in case of get request. So here we have the title, right? So now we have to perform various SQL injection payloads in here. So this is how, again, we can go ahead. In this case, since we do not have the web renderer in here, there is an option of render, and sometimes it does not render the web page accurately. So here, most of the time, you'll have to look for the text-based response, and based on it, you'll have to identify whether the error has happened. So in this case, the error message is clear. So now the approach which we are going to take in here is pretty much the same, right? So here we have the various payloads. We are going to inject it to see if the response changes. And now if we scroll down, we'll notice that we have all of the records. So these are the HTML content, right? We have TR, which is starting off a row. Then we have the column defined Iron Man. Similarly, we have Man of Steel. And then here are the closing rows. So now we have the entire content. So this way, this is how we are going to perform the injection in case of post request. What we can also do is in the proxy tab itself, in case if you want to have the view in web application or the browser itself, instead of, let me go back in here. Instead of sending the request to repeater, you can go ahead, modify the request in here directly and forward it. So this way the request will be forwarded to the browser and the view will be rendered on the browser itself. But in this case, the issue is you'll have to intercept the request back and forth to, again, in case if you want to have that view. But while you're performing pen testing, I personally think it's the best way to use repeater, because again, it makes string search and all of those operations very, very easy. So this was SQL injection. So this was basic SQL injection. And this is one such example. We have a real world application called free article submission. This is a home lab. You can try this one out. And apart from this, we also have open supports. This is again another real world application. So let me take you to the web application pen testing basic section. So here we have the OWASP top 10, and now there are various kind of SQL injection attack. We have again union based, error based. We have blind, boolean based, time based SQL injection attack. So I'll recommend you to try these out. So we have currently seen the basic SQL injection, and this is again the union based SQL injection, error based, blind based, and blind time based. So how many of you have used tool called SQL Map? SQL Map is one of the most, personally, I feel it is one of the top most used tool in pen testing. It makes SQL injection a lot more easier. And I can guarantee you that many of the pen tester might not be aware how to exfiltrate data by performing a blind Boolean based SQL injection or blind time based SQL injection. These are a couple of difficult techniques to execute because it's time consuming, and if we are manually doing it to exfiltrate data, it's going to take us a lot of time because we have to check the time, perform character by character comparison, and all of those operations. But SQL Map, the beauty about the tool is it performs a lot of complex operation. It executes so many complex query that it makes our job very, very easier. So the best way to, again, exploit and check for vulnerability would be to use SQL map, but I'll recommend going through these labs first. And in all of the labs, I have created the video in the similar format. For example, I have the text editor open in here, and this explains what is the behind the scenes query. So you can go ahead, understand how is the query executed and how you can exfiltrate data. So these will provide you understanding of how to exfiltrate data and how SQL map is doing it behind the scenes. So apart from this, once you are done with this, you can go ahead, use SQL map to attack various web application to dump out the database. So next we are going to take a look at NoSQL databases. So now the major difference between SQL and NoSQL database is that SQL database is relational, and NoSQL database, there is, again, we have key value data store, we have column based, graph based, document based. So it is commonly known for the unstructured format. So now let me quickly take you to the DynamoDB consoles. How many of you have used DynamoDB? Anyone? So let me go to the US East 1 region. So now, unlike SQL database, so let me, just a second, let me delete. So here, this is how easy it is to create a DynamoDB table. So I'm currently in AWS console. Here we have to provide a name of the table. I'm going to mention this as user, and user already exists. So I'm going to create user 123. Now I need to provide a partition key, which is again the primary key based on which indexing and querying is going to be performed. So here I'm going to mention this as name, and I'm going to click on create, and it's going to take a couple of seconds, and then it is done. So now we can go ahead, create item in DynamoDB. So it's going to take a few seconds. Yeah, so it is created. Now we can go ahead, create an item. So here I'm going to navigate to text, and here we can notice we have the partition key or primary key mentioned in here, right? So this has to be unique for all of the data which is stored in DynamoDB. So I'm going to mention another property or attribute. So I'm going to mention this as type, and let's mention this as ABC, and let's mention class as developer. So now I have an object, right? And here I can go ahead, create another item, which is like this. And here now I need to have a unique primary key for each and every record which is there. So here I'm going to mention Tom, and here I'm going to mention type as DEF. Now, as you can notice, the beauty about DynamoDB is that, or NoSQL databases, is that we can store it in unstructured format, right? There is no relational database in here. We can define a property which does not exist in other object. So here we have one which has name, class, and type. Here, the second object does not have the class attribute, right? So that's the beauty about DynamoDB. Now there are two operations in case of SQL or NoSQL. Here we have scan operation, and here we have query operation. Now let's take a look at the query operation first. So whenever we are performing query operation, it is a way of searching all of the objects. So here we can mention the partition key only. So while we are performing query, it can only search by the partition key. So that's why query operation is faster than scan operation. So here I can mention the string value as Tom. So it's going to provide us with this specific record. Now here the restriction is that we can only use partition key, right? Now this is resolved in the scan operation. So in scan operation, we can go ahead, mention any attribute name, and here we have the type of the attribute, and here we have the comparison operator, right? So here we can mention class as developer. Now I know that this does not exist in this object, but it exists in another object, so it is going to match, and there we go. So this way we can have any attribute mentioned in here, such as type ABC, and it's going to return a value. Now, the important thing to note here is this comparison operator, right? So now let's say I'm going to perform a check, which is going to mention, just a second, greater than star. So can anyone tell me what will it return? I'm going to compare type string with star. So now what happens is, again, this is greater than. So here it's going to compare, again, whether the string matches and compares with star. And in this case, it is going to return us all of the records. So this is, again, one important comparison when we are performing with string operation. Similarly, if we'll use space, it is going to return us similar result. Now let's take a look at another demo, which is, again, SQL injection on DynamoDB. So now previously I have mentioned that DynamoDB is a NoSQL database, right? But how is SQL injection possible? Anyone? Is there a possible typo, or it is whether it is possible to perform SQL injection? So now, so back in November 2020, Amazon added the support of part-3 for DynamoDB. So this facilitates developers to use SQL compatible query to execute on DynamoDB, which in turn behind the scenes is converted into various kind of scan query statement, and then it returns the results. So using part-3, we have the ability to perform SQL-based query operation on DynamoDB table. So that's, again, this was introduced back in November 2020. So now the importance about this feature is that, for example, let's say we have an application, right? So let's say we have an application which uses a SQL database. Now the developer wants to migrate to NoSQL database such as DynamoDB, right? So in this case, they have written the entire code base on SQL query statement. So what will happen is, for some of the operation, they might not have to change all of those SQL-based operations, right? They can directly simply migrate to part-3 and then use the database as DynamoDB instead of SQL, and the application might require less changes. And another reason is that part-3 and many developers are familiar and prefer SQL-based statement usage over NoSQL-based, again, query expressions. So that's why, because relatively it is easier. So if we'll take a look at DynamoDB, and if I'll go to text, this is a normal JSON, right? In case of DynamoDB, the JSON will look like something like this. So this is the name of the property. This is the type of the property. S stands for string. And here we have the value of the property. So now while we're performing various kind of scan query operation, we have to provide input in similar format. So we need to mention what is the type, again, what is the value, what is the name of the attribute. And while building out applications, sometimes it is little painful, right? So that's why, again, part-3 has definitely eased the querying and various operation on DynamoDB much more easier. So this is how the DynamoDB JSON looks like, and this is how the normal JSON look like. For example, if I'll add one more value in here, such as maybe roll number, and I'll mention it as 52 or 50. And if we'll take a look at DynamoDB JSON, here we can notice that n is there, right? So this is for integer, and then we'll have one for Boolean, and similarly there are other types as well. We have list, map, there are L, M, bool, all of those various kind of value attribute types. So next, let me quickly bring up a video on how to perform SQL injection on DynamoDB. Just a second. So before we take a look at this one, let me quickly also show the code behind the application. So this is in the US Eastern region. For some odd reason, it is taking a lot of time. Just a second. This is the function. So now here what we are doing is we are fetching the username, which is again the value which is sent in the name parameter. So this is how we fetch the value. So this is again the Python code which we have. So we are storing that name in username, and similarly we are storing the password in the password. We're fetching this from the parameters which are sent in the URL. Now we have this block of code. So can anyone point out what is the mistake in this block of code? So is there someone who is not familiar with Python? So no sanitization is the first issue. There is one more issue. And it's a big issue. So many of you got the first one right, which is again, there is sanitization issue, due to which again, the user controlled input is directly injected into the query statement, which is this one. There is one more issue apart from this. Yes, that is correct. The stack trace error, right? So the people who are not familiar with Python, what is happening in here is we are trying to execute a statement, and then if it fails, we have a try except block, right? So when we have this block, if the statement fails, then it is going to execute whatever block of code is there in this section, which is under the except section. So here, if the statement fails, we have a return statement which says status code is 500, and then it is going to return us the stack trace, right? So now this is a common practice developers do, and the reason behind this is, just a minute, let me show you the CloudWatch service. So now we know that, just a minute. Yeah. So now we know that there is an API gateway, right? Which in turn is triggering the Lambda function. Now the Lambda function is where all of the function code is executed, and the logs are stored on another service, which is CloudWatch. So now things are a lot different compared to traditional architecture where we have Apache and all of the logs are written in a file called var/log/Apache. And then we have error.log as well as access.log, right? So these are the file where we store all of the error in case of Apache. Now, in case of CloudWatch, this is a separate service altogether, right? So now for debugging purposes and to identifying what error has happened, the process has become slightly painful. So if we take a look at the CloudWatch service, just a second. For some odd reason, I think either my laptop has slowed down or my internet is running a little slow. So I'll explain the query statement in just a minute. So here, this is the CloudWatch service, right? And now in order to identify an error for a specific Lambda function, so let's say we are triggering or calling this Lambda function and an error happens. So now in order to identify that, what we'll have to do is we'll have to go to the corresponding CloudWatch log. So here we can notice we have a lot of functions which are there in the region, right? So these logs are for those functions. So this is the example of the SQL injection function. So now whenever a new Lambda environment is created, right? So for example, when we are triggering a Lambda function, a Lambda environment is brought up. So for each Lambda environment, we have a log group. So as we can notice, we have a long list of execution. So now in order to identify the core reason behind an error, first of all, we have to identify which log group was active at that time. So for example, we'll have to identify the time. So here we have 12:05 a.m., right? So now let's say an error happened at 12:30 a.m. So in this case, we know that this is one log group, and now this starts at 12:37 a.m. So this indicates that the error would have happened in this log group, right? Because again, whichever error happens before uh, this log group will be in the previous log group. So now we have to go inside this log group, and then we have to identify the exact time frame. So here we only have 3, right? But in many cases, what you'll find is you'll have a long list of uh, log group. So let me go in here. I'm hoping, no, it is also short. So if we take a look at some of them, we'll find that there are a lot of them. So all of them have 3 right now. Let me show you for another function. So as we can notice, we have multiple of these, right? Similarly, we'll have a lot of them, and it becomes quite painful while you are making changes back and forth, and you have to identify what is the core reason behind the error. Now, this is a common practice which the developer do. So this way, what happens is when they're sending out the request, the error message itself is sent in the response. So this way, it makes it slightly easier to debug the core reason behind the error. Now, this is good as long as the application is in the maybe development environment. But if it is in the production environment, these minor hacks have to be removed, right? Because in production environment, this will provide the attacker with all of the critical information and how to, again, go ahead, create the payload, which can be leveraged to perform an attack. So now this is the query statement which we have, right? So here we have select star from, this is again to escape the double quote, and this again to escape the double quote. And we have username is equal to single quote, start of single quote, and then we are appending the username and password in this query. So this is very simple concatenation. We are simply injecting the username and password inside the single quotes. So that's what we are doing in here. Now let's go back to the demo. Now this is the application. So here we are going to provide the credentials, and we'll notice it says login failed, and all of this data is being sent in the parameters. So now we are going to try and inject the simple or 1 equal to 1 payload. And if we'll try to submit it, it throws an error. So it says one or more key attribute values are not valid. The attribute value for a key attribute cannot contain an empty string value. So can anyone tell me what is the issue in here based on the error message? How are you going to modify the payload to get across this error? Encoding is not the right answer. The error message itself is quite explanatory. The attribute value for a key attribute cannot contain an empty string, right? So when we are injecting or 1 equal to 1, so let me go to the slide. So when we are injecting this specific statement, so this is again the SQL query which we have. And when we are injecting this specific statement, this is the payload which we are injecting, right? Or single quote or 1 equal to 1. So this becomes, this attribute has an empty value. And similarly, this attribute has an empty value, right? And here it says attribute cannot contain an empty string value. So what will we have to do in the payload, or how will we have to modify the payload? Anyone? Now here we can notice that this is again, yes, that is correct. So finally someone Got it. So now the main purpose in here is that we cannot have empty value in part-QL, right? So these cannot have empty value. We need to pass some value to it. So this is where we are going to modify this payload, and we are going to prepend a text to it so that the query becomes something like this. Username is equal to a value and password is equal to some value. So this way, the constraint of part-QL is satisfied, and we are able to again form a valid SQL statement. Now, this does not matter if the condition is true or false. It only needs to match the part-QL syntax, which is again, the attribute cannot have empty value. So these conditions are going to be true or false. It does not matter. This is going to be always true. Similarly, this is always true. So this makes the entire statement true. So this way, if I'll inject ABCD in here, which is again a normal, simple plain text, and we are going to submit, we'll be able to bypass the authentication. So now the error message here itself is the giveaway, right? So we'll go back in here. The error message itself provides us with a lot of information. The attribute value for a key attribute cannot contain an empty string value. So if the error message was not there and the application had returned or behaved in a normal way, then attacker would have to perform various SQL injection payload to identify the vulnerability. So in this case, since we are injecting, let me go back in here. This is the final query, right? So this is always true. So it is not always required to inject double hyphen for the comment. It is optional. We can either use the or 1 equal to 1 direct payload, or we can use the comment based payload. So this is again the final query which is executed. So here we have the true statement in both of them, right? So that's why it is going ahead. So any questions so far? Any questions? Okay, so now we have a different type of SQL injection. We have typical SQL injection attacks, union-based, error-based, and then you have blind SQL injection, Boolean-based, time-based, and then there is also out-of-bound SQLi. You'll be able to find labs for these in attack defense in the A1 injection WASP top 10. So this again, all of these labs, I'll recommend trying these out before you start with SQL map, because again, once you use SQL map, it is a very addicting tool when you are again performing a SQL injection attack. So most of the time, once you identify that it is vulnerable to SQL injection, you will use the tool right away. So now, next we are going to take a look at NoSQL injection. But before we continue with NoSQL injection, let's take a 5-minute break, and then we'll continue with the session. Welcome back, everyone. Next, we are going to take a look at NoSQL injection on DynamoDB. So let me quickly bring up another video. So here we have a very simple application, and you'll notice that many times we have on web pages, web applications, we have advanced search option, right? So now these search feature send out a lot of options to the backend. So this is one such example. Here we have a drop down. So here we have a drop down where we can go ahead, select the filter, and then if you'll notice, the comparison operator is set to equal to, and this field is disabled as of now. So we cannot change this, right? And this makes sense. For example, currently the value is string, right? So they should not have a other operator. It should be always equal to. The comparison operator should be there in case of numbers, right? So in this case, we have selected the filter as last name and we have the value James. We simply search and it provides us with the result. Now, what we are going to do is we are going to, as we can notice, there is no parameters. So that's why we are going to go ahead, inspect the request which is being sent. So we are going to intercept the request first of all with burp suite. And then we are going to send out the same request again. And here we get a post request with this specific post body data, right? So this is again a JSON, and here we have property, which is the last name, comparison is EQ, type is S, and values is James. So can anyone tell me from this JSON property or JSON object, what can you guess as an attacker? So couple of these we have seen them already, right? In a DynamoDB console, we know that there was something called S, which is again corresponds to string, and similarly we had comparison operator, right? And the value is James, and the name of the property is last name. So this is again the name of the attribute. So if we take a look at the DynamoDB section in here, we can mention the name of the attribute, we can mention the value, we can have the type mentioned in here, and then we can have the comparison operator. So this again has a lot of similarity, right? So probably what might be happening is this information is being used to create some kind of search filter or a scan filter. So now again, EQ stands for equal to, type is string, value is the attribute value. So we are going to forward the request, and next we are going to change the filter to age. And now we have a comparison operator which is enabled. So here we can select greater than, less than, and we can mention an age. So now here we have another request which is intercepted, and we have the property set to age, comparison changes to GT, and then we have type set to N, and we have value set to 22. So N again is integer, right? We saw in the DynamoDB JSON. So this indicates that probably this is used in formulating the filter. So now what we are going to do is we are going to search for DynamoDB scan filter. And here, let me go back in here. So we search for DynamoDB scan filter because again, now the property value are changing, right? We are using last name, we are using age, all of these property. So now we know that this is not a query operation, this is a scan operation. And here we can notice how the all of the property name, all of the type of property, everything is being called. So here we have a very simple scan filter which says the name of the property. So this is the name of the property. And then we have the value of the property in here, right? So this is again type of the property. And then we have the value in here. And this is the comparison operator. So now we know that all of this information is passed by the client end, right? So we are going to use this information And so all of this information is passed from the client end. So now many times what happens is sufficient checks are not being performed on the server side. So this is a big issue which happens. Many times developer enforce check on the client end, and then they do not enforce the check on the server end. So now here we have a couple of comparison operator, right? So can anyone tell me which of these comparison operator can you abuse? So now we know that we have already seen GT, we have already seen, just a second, we have already seen GT, we have already seen EQ, contains. So we have to dump out all of the records. Yes, that is, we can use not null, we can use not contains, we can use not equals. So all of these can be used to dump out the entire records which are present in the DynamoDB table. So next, what we are going to do is we are going to use the GT operator on the last name or the username field. Now here we have the property, we are going to set this to username, and then we are going to use the GT as it is. We are going to change the type to string, and here we are going to mention star. So there's a typo in here. There is any string, star will be again less than any string. This condition is going to be always true. So this in turn dumps out all of the records. So it goes ahead, checks for all of the records, and it is going to match that username. It is always going to be greater than star, and that's why it is going to dump out all of these values. Now similarly, we can use space as well. So these are again specific to DynamoDB, right? So this won't work in case of MongoDB. This is very much specific to DynamoDB. Now similarly, what we can do is we can use not equals. So here we are changing the condition to, or comparison operator to not equals, and we are basically checking dump out all of the data which does not have username equal to random string. So now we know that this is a very random string and no user might have this specific username. So this will go ahead, dump out all of the records which does not have this string. And similarly, we can go ahead use not contains as well. So this way we can dump out all of this information. Now, this mistake is a very common mistake which developers make, right? So whenever there's complex processing which is happening, or whenever there are too many options, for example, in advanced search field, they directly take in the data and they send it to server, due to which there is again lack of sanitization which happens. And here we can notice the comparison operator should always be equal to. The server had to enforce this check that whenever we have a string property of type S, we have to enforce that comparison operator is always equal to, and no other comparison operator can be used. But again, as we are moving on to single page applications, as more and more logic is being enforced on the client end instead of the server end, and these kind of mistakes happen very commonly. So one of the critical mistake is that the user input is directly being used to create the filter the scan filter. And another mistake is that there is no server-side sanitization or server-side check to again make sure that these are dangerous combination which can ultimately lead to injection on DynamoDB. So any question in this part? So this is again, these statements are always true. So that's why space as well as star. And now we are going to take a look at XML external entity. So how many of you have performed this attack, XXE attack? Anyone? So in case of XXE, what happens is we have a server, which is again running an XML parser. Now, as an attacker, we can go ahead, provide an XML document to the parser, and it goes ahead, processes this XML. Now, if this XML parser, again, if the web application or the program itself is not checking for the provided user input, and this XML parser is poorly configured, then what happens is the XML parser will go ahead, process this XML, which in turn might have external entities, and it goes ahead, sends out request, fetches the file, and we can perform various kind of attack if this XML parser has allowed external entity to be used. We'll talk about what exactly external entity is just in just a minute. So now, in case of XXE, what might happen is the XXE payload is provided to the XML parser. It goes ahead, fetches the external entity from etc password. It is going to fetch all of the data, and then it is going to return back the data to the attacker. Now, XXE injection can lead to reading files, reading local files. We can leverage XXE to perform server-side request forgery. We can exfiltrate data through blind XXE attack, and we can also retrieve data from error messages through blind XXE. Now let's take a look at the payload. So here we have a simple XML payload. So here there is something called entity. So whenever we want to define an entity, we need to enclose it into a doc type declaration. So this is again the doc type declaration which we have. This is required to define an entity. Now here we are defining an entity called welcome. So this is the entity, and we are storing the value hello world in that entity. And then later on, we are referencing this entity like this: ampersand, name of the entity, and semicolon. So now what will happen is when this XML is passed, it is going to check that there is a doc type definition, and it defines an entity named welcome with the value hello world. So after that, uh, this is the closing doc type declaration. This is the start of this part. So after that, what will happen is it is going to process this XML payload, which is this part. It is going to check that there is a reference to an entity, and it is going to use that value in here. So this way we have a XML, which is data, text, and hello world text data. Now in case of external entity, what happens is, just a second. In case of external entity, we use the keyword called system. So whenever we want to fetch some data outside of this entire XML, we have to reference it, or we have to fetch it externally, right? So that's why we reference it with the system keyword. This indicates that we are fetching data from outside the XML. And here we have a value, right? And can anyone tell me what exactly is this? What exactly is this string? Anyone? Uh, etc password is the file which contains all of the user information on Linux, right? So that is absolutely correct. But I'm asking, what exactly is this string, entire string, file colon slash 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 etc slash password? Not just the etc password file, as etc password part. Yes, that is correct. It is a URI. So if you notice, for this entire bootcamp, I have been playing the videos on the browser itself, right? And if you'll notice here, we have a path. So here we have a file colon slash 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 slash. So this is basically a URI which references a local file. So if I'll go in here, you'll notice I have the entire file directory listed in here, right? So this is a URI through which we can reference local files. So if I'll go back in here, this is a URI, right? So here we are referencing a local file, and we are basically telling the XML parser that we are defining an entity which fetches data externally from this file. Now, the reference, or by externally, we mean that the data is fetched from outside of the XML, although this file is locally held, right? So in this place, what we can do is we can have HTTP, we can have HTTPS, we can have FTP, we can have all of those protocols mentioned in here. So thanks for posting it. I was going to show it later on. So this is again the URI syntax which we have. We have a scheme, and then we have colon slash slash. So this is an HTTP scheme. So here we can notice we have HTTPS colon slash slash. Then we have the entire URL. Similarly, we have an LDAP scheme. We have a mail to scheme, right? So based on these, there can be multiple scheme. So we have seen HTTPS. In here, we have seen the file scheme. And similarly, we have FTP, we have dict. All of those are mentioned in here. Just a second. This is the one. So as we can notice, we have a lot of schemes, right? One of the critical one is dict. So with dict, what we can do is we can interact with database servers. So what we can do is with XXC, we can go ahead. Let me go back to this one. With XXC, we can go ahead and interact with various URIs. So in this case, what we are basically doing is we are creating an entity named password, and we are fetching the data which is present in etc password local file, and then we are dumping out that information in here. So this is a simple XML payload. So now let me quickly bring up another video. So here we have a mutility vulnerable application. So I'm going to forward this a little. So we are going to identify the open port and we are going to access the application. Next, we are navigating to the OWASP 2017 A4 XML external entity, XE injection, and XML validator. Yes, we'll take a look at that in just a minute. It is very, very severe. This XXE attack, all of these attacks are very severe in case of serverless architecture. We'll take a look at how to interact with various URLs in just a minute. So first of all, we are trying the basic XML payload. So here, this is a very simple XML. We have message, name, closing, name tag, and then we have the closing message bar. And then we are going to validate the XML, and it parses the content which was present inside the XML, so which is John, right? Similarly, we can go ahead, have the doc type defined, and here we can define an entity. So here, first of all, we need to have the doc type declaration, and then we are going to define an entity named password, and we are going to refer that this is an external entity. Fetch the data from etc password file. So this is the doc type declaration. Next, we have the XML definition, which is again the data text field. Then we have ampersand password to refer the entity which we have created previously. And then we have the data closing tag. Now, similar to the previous one, so here you can notice the difference is that we are referencing a entity, and here we had directly mentioned the value. So now, if we'll go ahead, click on validate XML, it will return us all of the content of the etc password file. So at this point, can anyone tell me what is or what all you can do with the information which is provided in here? What can you do with the etc password? Yes, that is correct. We can go ahead, once we have identified that these are the users which are there on the system, we can perform dictionary attack on the SSH service or the telnet service which might be used by the server. Now, this was again a very simple XML external entity attack, right? So now let's take a look at how to get the data onto a server. So how many of you have used Python HTTP server? And is there someone who has not used Python HTTP server? So let me quickly explain this for the people who are not familiar with the Python HTTP server. So let's say we have attacker machine, here we have the target machine. So this is the attacker, this is target. So now let's say we want to transfer a file from the attacker to the target. So what we are going to do is we are going to start a simple HTTP server. So in the newer Python version, which is Python 3, we have http.server. So we can use this module to host a server on the attacker server or attacker machine. So here on port 9000, what we are doing is we are hosting all of the files which are present in the root directory. So in whichever directory we start the Python HTTP server, in this case, we are starting it in root directory. If it started in temp, then all of the files present inside the directory are hosted on this specific port. It's basically a simple HTTP server. And what we can do is then we can send a request to this specific server from the target machine to download a file. Now, similarly, let's say we want to get some data from the target onto the attacker machine. So this could be, again, some sensitive data such as username, password, right? And whenever we are performing any kind of blind attack, this is a common approach we take. We send out the credentials or any sensitive data to the HTTP server, because once we'll send out a request, for example, let's say we are having the IP address 192.22.35.2 is the IP address of the attacker. So this is the port, right? So once we send a request to this specific endpoint with the parameters such as question mark username is equal to some value and password is equal to some value, so that is going to appear in here, because again, this is a request which we are sending, right? So now whatever request we send, all of the data in the GET request will appear line by line in here. So this is why we commonly use HTTP server, and it eases the pen testing process a lot, especially when we have to transfer a file. So now what we are going to do is, now we know that this is a URI, right? So we can change this into other scheme-based URI. So we can use HTTP, we can use HTTPS, FTP, whatnot. So now we are going to send out a request to the attacker machine and on this specific port, which is 9000. And we are going to simply mention that path is hello world. Now there we go. So here we can notice we have received a request on hello world. Now if we had placed a parameter such as question mark username, that too will appear at this point. So this way we can go ahead use Python HTTP server to fetch some data as well as to again send or fetch a file on the target machine. So any doubt in this part? So this was again the demo which we just saw. And next we have a home lab. This is again a real world application. So here you can go ahead perform XXC attack. And I think it's also possible to get RCE from this attack. So next we are going to take a look at what can happen if we have an XXC attack on cloud applications. So we are going to use the same payload in here. But before that, let me quickly show you the server-side request forgery demo. So let me go to the attack defense. So this lab is available under Lambda, and inside server-side request forgery. Now we know that with XXE, we can go ahead perform server-side request forgery attack, right? And this is very, very severe in case of, especially in case of cloud native applications. So just a second. So here we have the URL of the application. So now many of you might have encountered this kind of site, right, which provides us a feature to check the site availability. So now this, again, the purpose of this site is to provide users a way to check whether the site is available. And this is commonly used in case if someone feels that their IP might be blocked or banned from accessing a specific website. So here I have a simple web application, and here I can go ahead provide a URL. So I'm going to mention iplocation.com, and it did not work for some odd reason. Yeah, so google.com is working. I wanted to show the IP location. So since this is in the US East 1 region, the IP location would come out to be US East Virginia, North Virginia. But in this case, again, for some odd reason, the site is not working. So now as an attacker, what can you do when you have such kind of application? What can you do with SSRF? Anyone? With SSRF, you know that, so is there someone who is not familiar with the server-side request forgery attack? So let me quickly explain this one. Now, in case of server-side request forgery, what happens is we have a attacker machine, we have the target machine, right? So now whenever there's a server-side request forgery attack, what happens is the attacker goes ahead, sends out a request to the target, and then the request is sent out from the target to various places. So let's say we have another public server. This could be maybe Facebook, and this could be again Google, this could be GitHub, right? So in case of server-side request forgery, we send a request to the server. So let me write this as server. And then what happens is the request to these services or whatever our target is originated from this server. So that's why it is called server-side request forgery, because the request which you are sending is going to the target through this server. So similarly, what we can do is we can send a request to the server itself to query the local port such as 127.0.0.1, 8080, whatnot. So let me quickly draw this one out. Now let's say we have a server which exposes port 80 to the internet, and now we have a port 8080, which is again a service is running internally on the server, which is on 127.0.0.1, but the port 80 is on 0.0.0.0, right? So this is open to everyone, but this is running on localhost. So as an attacker, we will be only able to access the port 80 because this is on all interfaces, right? But if this server is vulnerable to SSRF attack, so let's say this application is vulnerable to SSRF, what happens is an attacker can send a request, and by leveraging this vulnerability, the attacker can make the server to send a request to this specific endpoint, which is 127.0.0.1 colon 8080, which is an internal port, right? So because again, this is a loopback interface and it is not exposed to the internet. So this way, the attacker will be able to get output of whatever data is being received by this specific port in here. So this way, as with SSRF, we can send out requests either to machines on the internet, as well as we can send out a request to ourselves to again go ahead, identify the open ports and perform various kind of attack. So here we have a simple application, and this Lambda function, it is running in US East 1 region, right? Currently I'm sitting in, just a second. Currently I'm sitting in India, right? So I'm in India, and here I have a Lambda function which is in US. So this request is actually sent by me from India to this Lambda function, and then this Lambda function is sending out requests to google.com. So it is sending this request from US. So that's why I wanted to show the IP location. So it would appear that the IP location would be North Virginia, US. So in this case, can anyone tell me what is the next step which you're going to take? How can you abuse SSRF? What is my IP.com? I'm not sure if it will work. If we have to provide some sort of input to it, it might fail. That's why I had selected iplocation.com. It is very easy to use site. So yeah, it failed. ipconfig.me. Okay. So this is again to find the IP address or the public IP address, right? I think it worked. Oh, it resulted into an error for some odd reason. I think it timed out. But any case, so as an attacker, what is the attack which you're going to perform? You know that you can send out requests from the Lambda function. So here, can we read the file? Because we know that this is a URL, right? So now at this point, we can go ahead. This is a URI. So we can basically send a request to the etc password file, which is there locally. And then we can dump out the uh, all of the user information. So can anyone tell me, is this information relevant to us? Or how can we leverage this information which is returned by etc password? Anyone? Valid usernames, we cannot actually brute force and gain access. This is because all of this is running on AWS, right? So this is again Amazon servers. So even with a username and if you try to brute force, if it is brute force, then you have identified a 0-day on AWS. So they're going to pay you a lot of money for that. But this won't be the case. We won't be able to again target the users on the Lambda environment. So what can we do at this point? Now this is a Lambda environment, right? What is the most critical information we can find from the Lambda environment? Anyone? Yes, that is correct. We have to find a way to get hold of the environment variable. Now the question is, how do we dump the environment variables? Print env, we won't be able to execute the command because this is again, we can send out request. We cannot execute a command, right? We can only send out request. So we can send out requests to local files. We can send out requests to, again, HTTP endpoints, whatnot. So which local file can we read to get hold of environment variables? Where are the environment variables stored in Linux file system? Anyone? Yes, you're almost on the right path. You're missing one directory from there. So here, now we have a file called etc. So this is one file which we have. I think I got the spelling mistake. I got the spelling wrong. So now this is one file where we have environment variables, but in this case, again, this file contains the system defined environment variables. But in case of Lambda environment, what happens is these environment variables are not there in the system environment variables. These are created on runtime. So these environment variables are actually present in proc self slash environ. So this is again a local file which contains all of these environment variables. So as we can notice, now we have the session token in here, AWS session token, and similarly we'll be able to find the access key as well as secret. So whenever there is an SSRF and it is not a blind SSRF, then we can pretty much identify the temporary access credentials. And now we know that once we have the temporary access credentials, this opens up a whole new window for the attacker to again perform various attack. From the temporary access credential, we can go ahead, enumerate other services such as again DynamoDB, S3, EC2, whatnot, and then it might provide us with more opportunity to perform various kind of attack. So any doubt in this part? How we were able to leverage the SSRF vulnerability to dump out the environment variables? Now, in some cases, what might happen is you might have to change the PID in here. So we might have to refer 1, 2, 3. Sometimes it might even take like PID 7 to identify or get hold of the temporary access credentials. In case of blind, we cannot dump out the environment variables like we are doing in this case, because you can send out the request, right? So even if you are trying to exfiltrate data, there has to be some other kind of vulnerability on the web application through which you can process the data which is returned by a request and then send it to the target request, target or the target server. So now let's go back to the XXE attack. So SSRF was not actually part of the bootcamp, but in order to understand what we can do with XXE, this was again a demo I had added. So this is the URI scheme which we have. So whenever we are referencing a local file, here we are referencing by relative path, right? So whenever we are referencing a local file by relative path, we do not have a slash in here. And whenever we want to reference by absolute path, we have the entire absolute path, and it starts with triple slash. So that's why you will notice sometimes you have double slash. This is because it's a relative path and we are referencing the file in the current directory itself. And whenever there's a triple slash, it is an absolute path. And this is again why we had mentioned triple slash in here. It was absolute part to etc password file. Similarly, we can go ahead, read the system environment variables. But in case of Lambda environment, the temporary access credentials are not defined in this place. It is actually in the proc slash cell slash environ. Uh, home user.ews credential, this will not work. Reason being, there is no user of that specific name. So it is not present in the Lambda environment. So .aws file, that directory is also not present. Credentials are not stored on local file. In case of, again, Lambda environment, they are stored in the proc slash cell slash environ and the environment variables. Now we are going to take a look at a demo on cloud environment, or basically on XXE attack on cloud environment. Let me quickly pick up the video. Just a second. So here we have a very simple XML, and here we have the uh, welcome to Pentester Academy Bootcamp's message, and that's why it is rendering all of this information in here. So what we are going to do next is we are going to create another simple XML. So I'll forward this a little. So here we have the hello world message and the closing of the XML. And upon parsing this, it will return hello world message. We are going to create the XXE payload, which is again referencing the external entity etc password. Now this way we can go ahead, dump out the etc password file content. But in this case, we know that this is a Lambda function, right? From the URL itself, we'll guess this is a Lambda function. So we won't be able to do much with the information which we have in this file. So it dumps out all of the etc password file content. Now we know that this information, we cannot attack the users directly, right? So the next option which we have is to read the environment or proc slash cell slash environ to dump out the environment variables. But in this case, it is going to fail. So for example, this is a Python backed application. So it is going to fail if we'll try to read this specific uh, file, which is proc slash cell slash environ. So can anyone tell me why it might fail? Anyone? If we'll try to read proc slash cell slash environ through an XML parser, it will fail. So the reason it is going to fail is because in case of XML parser, we cannot have null characters in the data, which is again being stored in the entity. So proc/self/environ, this file contains null characters, which in turn, when it is being processed by the XML parser, it triggers an error due to which the parser will break and it will not print out any data. So for the same reason, I have not included that part in the video, but if you try to read the file proc/self/environ, it will fail. So now the question arises, what can we do if the backend of the application was not Python and instead it was PHP? So if any one of you have developed application on PHP, you would be able to answer this. So there's a feature of PHP which can be leveraged to get hold of the file content. Anyone? Let me see if I can. Previously I was trying to find the video, but I don't have the video locally. So here we are taking a look at PHP runtime. So the previous application was based on Python runtime. So due to which the XML parser, when it was trying to read the file, it was breaking due to presence of null character. So in this case, the application is based on PHP runtime. And this is where, again, having or the backend as PHP runtime plays to an advantage of the attacker. So this application is going to look exactly like the previous one. And let me quickly forward this a little so that first of all, we are going to try the default XML payload, which in turn is going to return as an output. And let me forward this a little. I think the video quality went down a little. Just a second. So we are going to define the external entity. In this case, we are defining the normal XML entity first. So let me quickly forward this a little. So now we're going to try and read the Etsy password. So it is going to return us the content of Etsy password as expected. And now we are going to read the proc/self/environ file. Before that, we are also going to read the environment file. And this also works well. And since this file is empty, that's why we do not have any output in here. Now we are going to read the proc/self/environ. And this will trigger an error. This is because, again, for the same reason, XML parser is breaking due to null characters in the file. So while you are trying out the same operation on the previous lab, which is again the Python-based application, you will also run into the same error. So now the advantage of PHP language is that there is something called PHP filter, which we can use. So now what we are doing is we are looking for XXE payloads specifically for PHP language. And now if I scroll down in here, we'll notice that this is a feature available to PHP, and this is again available natively. We have not done any modification or added any additional libraries. So here we have a filter, and as the name suggests, it is going to encode the data into base 64. And this is again the resource which it has to encode. So now we have a resource which we can mention, and what it is going to do is it is going to encode whatever data is it gets in response from this endpoint. It is going to convert this into base 64, and then it is going to return it. So having the PHP filter plays to an advantage of the attacker. So this way, what we are going to do is we are going to mention in resource, again, the file-based URL file:///etc or sorry proc/self/environ. So this value is going to be placed in here, and this is going to be base 64 encoded, and then it is going to be returned to the user. So this way we are able to again convert all of the content which is in there. So this includes null character, right? So all of the null character, everything will be encoded into base64 format. And now we know that base64 is all but a set of characters, digits, and couple of, again, special characters. Now these all are supported in the XML parser. So it is going to, again, XML parser is not going to break. Yes, you can. But again, in this case, the issue would be to configure both PHP and Python on the same environment. It is going to be very difficult. You'll have to build out a custom environment or custom runtime. So this is, again, a completely separate environment. We have Python and PHP environment or PHP runtime. Both of them are separate. So that's why we have separate application based on both of these runtime. So now once we have identified, let me go back in here. So by using the same payload, which we fetched from the GitHub repository, and mentioning file is equal to, or the resource is equal to file colon slash 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 proc slash shell slash environ, we were able to convert or fetch the base64 encoded proc slash shell slash environ file. And now we have a long base64 encoded string, right? So what we can do is go ahead, base64 decode it, and then we are going to parse the file content accordingly. So we're going to use base64 -d to dump out all of the environment variables. Now, one issue that happens is the new line characters are stripped, right? So when we are reading the file proc slash self slash environ, that file does not have new lines. So now we have concatenated all of the lambda environment variables concatenated. So that's why we'll have to parse this ourselves, and we'll have to go ahead based on the AWS Lambda environment variables, we can go ahead, parse this accordingly, and then get the final environment variables. So this way, we are able to dump out the environment variables in case of XXE attack. So this is, again, I'll provide the video for this one. This is going to be lab 34, which is this one. I was looking for the video locally, but for some odd reason, I think it got deleted accidentally. So any doubts so far? The important thing to note here is, in this case, XXE, with Python, we were not able to do much, but with PHP, we were able to leverage the filter to dump out environment variables. So this is where you have to try various kind of payloads specific to language. So you'll have to use Python specific payloads to see how the application behaves. That's the only way. We won't be able to identify what is the backend by, again, couple of payloads. We have to hit and try to see if it works or not. And that way we'll be able to identify it. So any other questions? So next we are going to take a look at A6 security misconfiguration. So before we move on, in case if anyone has any questions, please let me know. In case of blind XXE, you can exfiltrate the data. So let me quickly show you a couple of other labs which you can try. I won't be covering blind XXE because, again, a couple of the operations which we perform are slightly advanced for the beginners. So that's why we have kept it for later on. So let me quickly go to the WASP top 10 here. So in case if you're interested in blind XXE attack, you can go ahead to the single page application, and we have covered blind XXE as well as all of these attacks in here. So we have vulnerable XML editor. So again, once you are, but please, I'll request you to first solve the labs which we are covered in the bootcamp, and then move on to these labs. So these are available under the other topic section. So this is, again, the other topic section, and then we have the OWASP top 10 single page application. So these are a couple of advanced lab, such as you have blind SQLi as well. So it might be a little difficult if you're trying this for the first time. So that's why I'll recommend all of you to solve the basic lab which we have covered in the bootcamp first, and then move on to all of these labs later on. So any other questions? So let me quickly close all of this. So next we are going to take a look at A6 security misconfiguration. Now this is one of the very common attack which happens, or one of the common misconfiguration that happens. So now let's jump into a video. So I'll quickly explain everything. So I'm going to forward this a little. So now we are going to perform nmap scan to identify the open ports. And here we can notice we have port 80 and 3306. Now the approach which we are going to take in this case is going to be slightly different. We are not going to attack the web server itself, but we are going to attack the SQL server. So here we can notice we have a simple web application, and this web application is not vulnerable to RCE. And this is a beautiful plugin called a Weblyzer. And here it provides us with information regarding what kind of operating system the web application is, again, the web server is running on, the programming language, and the JavaScript library, all of those. So it analyzes the response headers as well as the response, and based on this, it is able to identify all of this information. Now here we can know that the backend is PHP, right? So now what we are going to do is we are going to use nmap script to check whether there is any sort of password authentication on MySQL server. So here we have a script called mysql empty password.nec, right? So this is, again, all of the scripts are available in this directory, user share nmap scripts, and we are searching for MySQL to, again, only filter out the MySQL based scripts. And here we have the mysql empty password.nec script. So we are going to use this script, and as the name suggests, it's basically checking whether a user has empty password or not. By default, it is going to check for the user with username root. So since we have not passed any username information, it is going to use the default one, which is root. So this is, again, the IP address, and then this is the port on which the SQL server is running. And here it says root account has empty password. So now we know that MySQL server is configured with an empty root password. So what we are going to do is we are going to use MySQL client to connect to the SQL server. And we are going to mention the user as root. And this is, again, the host to which we want to connect to. And there we go. So now we are inside the SQL server. So can anyone tell me what is the next step which you're going to take at this point? Anyone? You have access to the SQL server. What can you do? Yes, that is correct. We can dump out the database information. But now let's say our target is to get remote code execution, RCE, on the box. And let's say the application does not have any sort of vulnerability, does not have a feature to upload file, all of these operations. Yes, that is correct. So Maximus is on the right track. We are going to upload a PHP shell. So now what we are going to do is there's a feature in SQL called, let me go back to the slide. So this is, again, many times what happens is we have to make sure when we are configuring various components, these are not misconfigured. If we get one security configuration wrong, it can cause a lot of problem. So this is where there's an option secure file priv in MySQL. Now what happens is this by default corresponds to the data path of SQL Server. So we have var lib/MySQL. This is, again, the default data path, right? So now what this allows SQL Server to do is it can go ahead, write the file into this directory from the MySQL shell. Now in this case, if we set this to empty, what happens is this means it can write the file anywhere on the file system. So here the misconfiguration is that this value is set to empty, due to which, again, the if empty, the variable has no effect, right? So this is insecure. So if we set this to empty, then the restriction is removed from SQL Server to write into the var lib MySQL directory. And this restriction is removed, which effectively allows it to write file anywhere on the file system, provided the path is writable. So if again the path is writable, it can write the file to anywhere on the file system. So this is again the misconfiguration which we have in this specific SQL Server. So first of all, what we are going to do is we are going to select hello world into out file, and then we have the path from mysql.users table and limit 1. So let me quickly explain this query. So previously we have seen the feature of limit, right? Now we have a table called mysql.user. So this is again the database which is there by default in MySQL Server. And this is again the table which holds all of the user information, such as again user root did not have any password, right? So all of this information is present in the users table. So this is again the database where all of this table is stored. So we know that this is a table which will always be there in MySQL servers, because again, all of the users have to be authenticated and this table is present there by default, right? So what we are doing at this point is we are selecting hello world. So basically now we are simply, this query, what it is going to do is, let's say we have maybe 10 records in this specific table. In this specific table, we have 10 records. So now when we mention that, let's say this is the name of the column, username. So now we mention select username. Just a second. When we mention select username from this table, what it is going to do is it is going to provide us with a value which is present in this column, right? But when we mention a value in single quote, so let's say we have single quote in here, then it is the literal string, right? So this string is considered directly as the output response. So instead of providing the value, let's say I have Justin in here, I have John in here. Now this statement, instead of returning Justin or John, it is going to return me username. This is because it is enclosed within single quotes. So that's why whenever we have any value enclosed in single quotes, that exact value will be returned by the statement. So now we know that we have a limit 1. So here we have 10 records. So what we are doing is we are limiting the query. So first think of this part. So let's forget about this part for a moment and think about this part, which is select hello world from mysql.user. Now let's say we have 10 records. So what it is going to do is it is going to print 10 user or 10 hello world back to back, right? So it is going to return us 10 hello world one by one. So it's going to be 10. Now we need to limit this and we need only one. So that's why we have limit 1. So it is only going to return us one record. So this is the first record and it is going to print out hello world, which is this string. Now what we are doing by this is we are telling it that write the response of the query, which is again hello world in this case, into the file temp/temp. So what happens is this data hello world, this response is returned into /temp/temp. Now if this operation succeeds, that means secure file priv option was disabled and we are basically able to write into temp directory, which is again outside the var lib MySQL directory, right? So this is again the MySQL data directory. And since this path is outside, that means the secure file priv option is disabled. So this is again the confirmation to check whether we can write outside of the MySQL data directory. And since this executed successfully, that means we can write. If there was an error, then it would indicate that we cannot write file to that directory. So now we have confirmed that, okay, this option is disabled. So what we are going to do is we are going to create a very simple PHP shell into the web root directory. So this is again a very simple PHP shell. we have PHP, then we have shell exec. We are going to fetch the parameter CMD from the GET request, and we are going to execute it and return the data which is stored in output, and we are going to simply echo the data out to the user. So now we have a very simple PHP shell, and what we are doing is we are writing it into the directory var/www/html/shell.php. And this also executed, right? So this was successfully executed. So can anyone tell me there is one more misconfiguration in here? What is that misconfiguration? There is one more misconfiguration. Secure file prev being disabled is one misconfiguration. There is one more misconfiguration apart from this. Yes, that is correct. So this directory, if we have, again, if you're following the best practices, this directory should not be world writable. MySQL service is, or MySQL server is running with MySQL user, right? So if it is running with MySQL user and it is able to write into this directory, that means the directory is world writable and it has the permission 777, or it has, again, -7. At the end, it has 7. Or other misconfiguration could be that MySQL server is running as root, which is even critical misconfiguration. So this way, there is two possibility. One, it is either root or this directory is world writable, which makes it possible for the MySQL service, which is running as MySQL user, to write into this directory and create a web shell. So now since this executed successfully, that means the file was created. So what we are going to do is we are going to access the file to see whether it was created, and then we are going to pass in the command to execute the command. And similarly, we can execute other commands as well. So can anyone tell me whether this is a container or whether it is an actual VM? Yes, that is correct. So again, the init process gives it all away. So any doubt in this demo on, again, how we were able to leverage a misconfiguration onto the MySQL server and a misconfiguration on the var www/html directory? So now please note, this is not a vulnerability, this is a misconfiguration, right? So that's what A6 security misconfiguration is about. So there is not a vulnerability. This is, again, some security mechanism has not been properly implemented, and due to which we are able to create a shell onto the root of the web directory, and this way we are able to get a shell on the machine. So the web application itself was secure, but due to this misconfiguration, we are able to exploit the misconfiguration and get a session or shell session on the server. So now we have another lab. This is, again, a home lab. So you can try this out after the session. And next, we are going to take a look at the importance of logging. So many times what happens is, let's say a dictionary attack is happening, right? So developers, they do not keep track of, again, all of the error messages, all of the logs which are generated, and they are unaware that an attack is happening. And if they do not block that attack in the right time, it could, again, allow the attacker to successfully complete the attack and steal sensitive information. So in this example, I'm going to show you the same DynamoDB PartQL SQL injection. So let me quickly go to the console of AWS. And here we have multiple Lambda functions. So one Lambda function is with logging, one Lambda function is without logging. So let me quickly, okay, let me quickly bring up the video to explain this one. So here we are attempting a couple of login attempts. So it says login failed. And now whenever, now at the time of shooting the video, we only had 3 functions. Now we have a lot of them. So that's why you'll notice some discrepancy. So here we have 2 functions, but there's DynamoDB particular SQL demo and one is without logging. So now in this specific Lambda function, we are not performing any sort of CloudWatch log monitoring. So we are not pushing any log to the CloudWatch. And in this case, it pushes the log to the CloudWatch. Now, let's say we have a user, right? And we can identify that this user is trying to log in if he has attempted maybe a password 1, 2, or 3, right? A user cannot get a password wrong 10 times. So this is a clear indication that a dictionary attack is happening. So we can go ahead and we have to log all of these attempts to make sure, again, that we detect all of these attacks and then apply the appropriate measure to prevent these. So as we can notice, when we are navigating into the monitoring section of this function, it says your function does not have permission to write to CloudWatch logs. So the logs are not being generated for this specific function. Now, if we'll take a look at this specific function, we have a CloudWatch log group which is created, and it is sending out all of the log information to this specific log group. So this is again DynamoDB particular SQLite demo with logging. And let me quickly show the source code of the application first, just a second. So this is again the function which we have. Now here, what we are doing is, here we are printing data to the CloudWatch log. So whenever we are performing a print operation, it is basically printing that information onto the CloudWatch logs. So here we have a simple hash event, and then we are mentioning that login attempt detected, and then we have the name of the user, which is again the username, and password is not actually required, and it is a bad practice to store the password in the log. So but in this case it is not actually required. We can remove this part, and then this is important, the IP address. So this way we get the IP address information in here. So now for every login attempt, what we are doing is we are basically logging the username as well as the IP address. So if we take a look at the logs, after every attempt we'll get login attempt detected, user John, and then we have a password. Similarly, we have another login attempt, user John, password AST. Now here the password is changing, that clearly indicates that it is a login dictionary attack. So now even if we did not have password, and if we find 10 of these entries, then it indicates that it is a dictionary attack. So what we can do is identify the IP address and then blacklist that IP address from accessing the application for certain duration. And here we can find another entry, right? And all of these are originating from the same IP address. So this is probably a dictionary attack. And at the same time, we can, for example, if the IP is blacklisted for a specific user, we can show a message that your IP is blacklisted and please contact support to, again, whitelist it and so on. So now we are trying out various attempts to, again, simulate dictionary attack. And this is another attack, which is SQL injection payload, right? And now it went ahead. And now all of this can be detected from the log. We can go ahead, print all of the information, and then we can process this log to check what kind of, again, username it is attempting and perform, again, blacklisting of a specific IP address. And this, for example, if you have this specific entry in the log, which is login attempt user is ABCD hyphen or 1 equal to 1, this is a clear sign that it is a SQL payload, right? So our code, which is processing the log, can have a simple condition that if SQL injection is detected, then block the IP address immediately. And similarly, we can force log-based check to, again, prevent more attacks on the application. Now, one of the issues we face in case of CloudWatch is that it is difficult to identify an error. So let me go to CloudWatch. So here we have so many log groups. Log groups is the place where we have all of the logs for the function. And now in this specific account, I have, I think, over at least 20 Lambda functions. So here we have 20, there are 21. So there are around like 22 to 23 Lambda functions, and out of which we are logging the logs for 21 Lambda functions. And here we can notice it is a long list. Now, in order to identify where an error has happened, where we have a lot of traffic and all of these, it is slightly painful. So this is a common approach which I take. Here we have an explorer metric. So here what we can do is mention the Lambda function, and let's say we want to identify error information. So we set the Lambda function error, select the metric in here, and then we are going to mention the property as function name, and here we can set a specific Lambda function, or we can set all values. So what it is going to do is it is going to check where an error has happened in all of the Lambda functions. So here we can notice, if I'll expand this one, we have identified an error has happened in SSRF Lambda function, which is this one. Now we can go ahead, change the interval. So this is, again, by default, it is for 3 hours. We can change it accordingly. We can have 12 hours, we can have 1 day, 3 day, 1 week. Based on this, we can identify where an error has happened. And then once we identify the time, for example, this has happened on, again, this is the time, right? So now we have a time information. We know that an error has happened in the SSRF function. So based on this information, we can narrow down onto the log group, and then we can go ahead identify the error message. Now let's say a dictionary attack or some kind of attack is happening on the Lambda function, and this in turn causes the duration of the Lambda function to increase, right? So we can also measure that in this specific section. We have Lambda function duration, and then we can mention that we want to track the duration of all of the functions. This way, what we can do is we can track the duration taken by the Lambda function to complete the execution. And based on this information, we can identify whether an attack is happening or not. And one good thing about CloudWatch is that we can set metrics and various rules to trigger alarms. And based on that, we can send out notification to administrator, to the developer, indicating that an attack is happening. So please take an action. Now, many times people do not, again, pay much attention to logging, which in turn causes a lot of attack to go unnoticed. And it also happens that attack is going on for a couple of months and people are not administrating it because they're not aware that an attack is happening. So any doubt in this part, why it is so important to have logging and monitoring of all of the, again, cloud functions, serverless architecture, and everything? Based on simple logging, we could be able to prevent a couple of attacks. No, actually, it would be, maybe you can go ahead, take a look at service such as CloudWatch, and take a look at, again, all of the information it is providing us. Otherwise, there is no direct way without looking at the code. In the code itself, we have to, again, have certain block of code which dumps out whenever a malicious activity is detected. Otherwise, we can go ahead, check the response time and the execution time. Based on this, we can correlate whether an attack is happening. For example, let's say we have a Lambda function which is supposed to complete the execution within 15 seconds, but for some odd reason it is taking over 200 seconds, right? So this is, again, a clear flag which we have. So this can be easily flagged from the CloudWatch service itself. Any other questions? Splunk, I'll have to check. I've not. Okay, Splunk, I'll have to check in that case. The team has used it. I'll check with them once and then I'll get back to you. Any other question? Again, at the end, it depends on how you're configuring everything, right? So based on that, again, if you're checking for the duration and all of these metrics, it might be able to identify that an attack is happening. Otherwise, in order to, again, take a preemptive measure against an attack, such as you need information which user is being targeted, from which IP address the traffic is originating, and then you'll have to blacklist all of them. Any questions? So how was the session today? So this is to answer the question of Nitisha. Do we need to write our own code/script in the exam because there are quite few different languages covered today? While understanding it is okay, not sure about writing it. No, you won't have to write much code. In case if there is a requirement of writing a code, what you can do is you can refer to the code script or the code snippet which we are going to provide in the lab manual, and you can directly copy them and use them in the exam. So I think you might require the code only in case of the deserialization based attack, which we are going to take a look at in the upcoming session. So apart from that, you won't have to write any programs or language specific code. Any other question? Yeah, there is going to be advanced web application pen testing as well. But again, we need to make sure that we familiarize ourselves with all of the basics first, and then slowly we'll take again baby steps towards all of the advanced concepts. So thanks again, everyone. I hope everyone enjoyed the session, and we'll see you next week with the last session of the bootcamp. Till then, take care. Bye-bye.